In this video, we will deconstruct Standards 4 NF5 and 4 NF6 of the Grade 4 Georgia Standards of Excellence for Mathematics. These two standards focus on fractions with denominators of 10 or 100 and the relationship between fractions and decimals. Standard 4 NF5 requires students to express a fraction with denominator 10 as an equivalent fraction with denominator 100 and use this technique to add two fractions with respective denominators 10 and 100. For example, students establish that 3/10ths and 30/100ths are equivalent fractions, and using this understanding, they determine that 3/10ths plus 4/100ths is the same as 30/100ths plus 4/100ths, which is equal to 34/100ths. Standard 4 NF6 calls for students to use decimal notation for fractions with denominators 10 or 100. Students determine that fractions such as 6/10ths and 29/100ths can be written using decimal notation. This standard also necessitates that students read, write, model, and represent decimal numbers, as well as locate decimal numbers on a number line. Grade 4 is the first time that students are introduced to decimal concepts, and Standards 4 NF5, 4 NF6, and 4 NF7 lay the foundation for performing operations with decimals in grades 5 and 6. In Grade 4, students investigate the relationship between fractions and decimals, read, write, and represent decimals, and compare two decimals to the hundredths place value position. In Grade 5, students read, write, and compare decimals to the thousandths place, use place value understanding to round decimals to the hundredths position, and use concrete models and drawings to add, subtract, multiply, and divide decimals to the hundredths place value position and relate the strategy to a written method. In Grade 6, students fluently use the standard algorithm to perform all four operations with multi-digit decimals. Let's start by looking at the expectations for Standard 4 NF5. This standard continues the work of equivalent fractions by having students change fractions with a 10 in the denominator into equivalent fractions that have a 100 in the denominator. For example, the model shows 5/10ths of the grid shaded. If the grid is partitioned into hundredths, we see that the same area, or 50 of the 100 squares, are shaded. So 5/10ths is equal to 50/100ths. Students need ample experiences working with visual models instead of algorithms in order to develop understanding for future work with decimal numbers. Standard 4 NF5 also requires students to add two fractions with respective denominators of 10 and 100. Consider the problem 2/10ths plus 7/100ths. Using their knowledge and understanding of equivalent fractions, students determine that 2/10ths equals 20/100ths. Thus, we can rename 2/10ths plus 7/100ths as 20/100ths plus 7/100ths. The model represents 20/100ths and 7/100ths for a total of 27/100ths. Another way that students might represent 20/100ths plus 7/100ths is with dimes and pennies, where 2 dimes is equal to 20/100ths and 7 pennies is equal to 7/100ths. 2 dimes and 7 pennies is equal to 27/100ths. Students need multiple opportunities to compose and decompose decimal fractions, including fractions greater than 1. Students can use number bonds and their knowledge of place value to demonstrate flexibility with numbers. One scaffolding task that can support students with Standard 4 NF5 is decimal fraction number line. This task requires students to create a model for each decimal fraction using a tenths or hundredths square. Students then use the decimal fraction models to create a number line. Let's watch as some students work through this task.
Which fraction are you representing?
9/10ths.
How do you know it's 9/10ths?
Because the numerator is 9 and the denominator is 10, so it means 9 out of 10.
So how many of those are you going to shade on your grid?
9.
How many are there in all?
10.
What fraction are you representing on your grid?
100 hundredths.
And how many tenths is equal to 100 hundredths?
10 tenths, which is Also 1 whole.
So how much of that grid are you going to be shading?
The whole thing, 100 hundredths.
After students developed their decimal fraction models, they developed a number line to reflect equivalent fractions with denominators of 10 and 100.
What patterns did you see as you completed your number line?
We saw that it went in 10, so 10, 20, 30, 40, 50, 60, 70, and so on.
Okay. What do you notice about 50 hundredths and 5/10ths?
They're both half.
What about 70 hundredths and 7/10ths?
They're like across from each other,
And what would that indicate?
that they're equivalent.
In the next section of the video, we'll investigate the expectations for Standard 4 NF6, which requires students to use decimal notation for fractions with denominators 10 and 100. In grade 4, students make connections between decimal fractions, such as 45 hundredths, and writing this number using decimal notation. Using a place value chart can assist students with developing place value understanding. Students also need concrete experiences to represent the magnitude of numbers, and base 10 blocks can serve this purpose. In this example, each rod represents 1/10 and each cube represents 1/100th. 45 hundredths can be represented with 4/10 rods and 5 hundredths cubes. Let's represent the magnitude of another decimal number, 2 and 72 hundredths. In this example, each flat represents 1 whole, each rod represents 1/10, and each cube represents 1/100th. 2 and 72 hundredths can be represented as 2 wholes, 7/10 rods, and 2 hundredths cubes. This can also be written in expanded form. 2 times 1 plus 7 times 1/10 plus 2 times 1/100th equals 2 and 72 hundredths. Standard 4 NF6 also necessitates that students identify and locate decimal numbers on a number line. After students have experiences using concrete models to show the magnitude of decimal numbers, they can use these models to develop a number line. Let's build a number line from 0 to 1 using base 10 rods. Each rod represents 1/10. Now, let's label the number line in both tenths and hundredths. We need to find and locate 38 hundredths on the number line. Starting at 3/10 or 30 hundredths, we need to count forward another 8 hundredths. The arrow shows the location of 38 hundredths on the number line. The task Decimal Designs supports students with Standard 4 NF6. This task requires students to write decimal fractions with denominators of tenths and hundredths in decimal notation. Let's watch as some students reason through this task.
What are you representing with your models?
4/10 and 0.4.
And how do you say 0.4?
4/10.
Are those equivalent?
Yes, they are, because in decimal form, it's pretty much the same thing as fraction form.
Tell me how you know that.
We have 4 1/10, so that'd be 4 times 1/10 is just like 4 times 0.1.
And how do you say 0.1?
1/10. 4 times 1/10 is 4/10.
What are you representing?
I am representing 10 out of 10 or 1 whole.
How do you know that?
I know that 10 out of 10 equals 1 whole because 1/10 is 1 part of 10. If there are 10 of those parts that make up that 10, 10 out of 10 equals 1.
Can you show me how you represented that on your paper?
I represented 10 out of 10 or 10/10 by putting the numerator as 10 and the denominator as 10. In decimal form, I put 1 whole because 10/10 equals 1 whole.
After students have ample experiences with decimal concepts, they begin to solve problems with decimals, which applies to Standard 4 MD2. Let's look at an example. Tyson spent $5 on a pair of sunglasses and a small pack of gumballs. If the sunglasses cost $3.48, how much did the pack of gumballs cost? Let's represent this problem with a bar model. We know that Tyson spent a total of $5. We also know that the sunglasses cost $3.48. We need to know the cost of the gumballs. We can find the cost of the gumballs by calculating $5 minus $3.48, which gives a difference of $1.52. The pack of gumballs cost $1.52. For additional tasks that support Standards 4 NF5 and 4 NF6, check out openmiddle.com. In this task, decomposing tenths and hundredths, students use the digits 0 to 9 no more than one time each to fill the boxes to decompose 1 and 1/10. Tasks such as this incorporate the standards for mathematical practice and encourage students to reason flexibly with numbers. Likewise, illustrative mathematics includes numerous tasks that can be implemented to support student learning. For additional information about the Georgia Standards of Excellence, please visit GeorgiaStandards.Org.